Cloud is all about choice. Take full advantage of multi-cloud with Couchbase, a geo-distributed, cloud-native data platform built to power your business-critical applications. Avoid cloud lock-in and open up a world of possibility. Start a revolution with Couchbase. Learn more at couchbase.com/cloud.
Hello and welcome to the InfoQ podcast. My name is Wes Reisz and I'm the host of the podcast and chair of the QCon software conferences brought to you by InfoQ. The next conference is in New York and it's June 27th through 29th and will feature 15 full-day tracks. Each talk at QCon is an individually selected and curated talk by our group of over 20 software domain experts. So at QCon New York 2018, you'll find talks about language innovations in Rust, Go, Elixir, Java, and more. You hear topics on ethics like GDPR. You'll hear Matt Klein, the creator of Envoy, talking about their design goals at Lyft. You'll hear about chaos engineering at Netflix, practical machine learning from SWEs. You'll hear about distributed tracing at Facebook using Canopy, and practical lessons on Kubernetes, radical candor, chatbot UIs, blockchain, microservices, and so much more. It's a packed 3 days. I hope you have the chance to check us out and look forward to meeting you if you do. On today's podcast, I'm talking to David Wells. David Wells is a senior software engineer working at Serverless. You may have heard of the Serverless Framework. It's a product that Serverless produces. They're also working on a cross-cloud, event-driven open source framework there at Serverless. David spends his time working on the Serverless Framework and helping others leverage it. To provide some context, if you've ever typed the word serverless deploy using the Serverless Framework, you likely got a message congratulating you on your first deploy from our guest today. Prior to that, he was lead developer at MuleSoft. On today's podcast, we're talking about serverless adoption, kind of some of the stories around the scale of serverless and what's being done out there in the industry. We're going to talk a bit about the serverless framework and the role that it plays in the space and kind of the value add that it offers. And we'll talk about lots of lessons and tips on how to build serverless applications. It's a great podcast. Hope you enjoy it. David, welcome to the InfoQ podcast.
Hey, thanks for having me, Wes.
You bet. Been looking forward to it. So we all know that serverless sort of abstracts away at least the idea of managing servers from the developer. It's like literally letting us focus down to a function, maybe a unit of execution. In other words, focus on the core business competency. It offers pay for execution, never idle servers, auto scales, event-driven. And if you couple that together with all the other things that a cloud provider offers, like AWS, the options are like limitless. So tell me, was Frederick Brooks Jr. wrong? Is serverless the silver bullet?
Serverless is the silver bullet in most cases. It really does abstract away a lot of the things you had to worry about previously in the VM space and kind of in the container world. There are some cases where it might not be as cost effective or the right way to go. But yeah, you kind of hit the nail on the head when you said it really abstracts away. First, it's a little bit of a misnomer. Everyone really gets hung up on the name serverless because, of course, there's servers somewhere. It's just that the developer doesn't need to worry about them or manage them anymore. And I always equate it to, is your wireless router actually wireless? If you go to where it's plugged into a wire somewhere, right? You just don't need to think about it. So the name kind of stuck and yeah, here we are.
There's some interesting stories out there about kind of serverless adoption. One in particular that we talked about before we started recording was with FINRA. Can you talk a bit about maybe the FINRA use case or some of the other use cases that really show the power of serverless?
Yeah, sure. So FINRA is a financial regulation institute. It's not part of the government. It's definitely related, where they basically are validating stock trades, and they're processing 500 billion stock validations a day, and that's all running on Lambda. And that's to do with like the heavy basically load that undertakes. Highly recommend checking out the Serverless State of the Union from every year. They do that at reInvent, but they have some of these kind of case studies in there. But that was one of the big ones. And then as well as, like media companies like Vivo. So they do, whenever like Kanye drops a new music video, let's say, they post it out there and they need to handle a huge influx of traffic. So they're actually using Lambda to handle those spiky loads.
Do you happen to know numbers by any chance to kind of give us an idea of what it means when you say scale?
So with Vivo, they were handling basically 80 times their normal traffic load. And yeah, the FINRA was at 500 billion.
Okay, so as you were talking there, you said there's some use cases where serverless makes a lot of sense, but there's some other ones where it may not be as cost effective as maybe some other solutions. What are some of the cases where serverless makes a ton of sense and others where it maybe doesn't make so much sense?
Yeah, sure. So where serverless makes sense is really if whatever it is that you're doing runs under 5 minutes. So right now, with most of the major functions as a service providers, there's a 5 minute like hard limit on how long your function can execute. So if you're running like huge batch jobs that take longer than 5 minutes, you would want to run that in your, EC2 instances or in your, Kubernetes cluster. That's one of the cases where it kind of breaks down. There are some workarounds to that. They're not really recommended. You can recursively call functions to supersede that. You want to be very careful if you do that. And again, not recommending that you do that. Other places where serverless isn't really, in my opinion, ready for prime time is you can't really do WebSockets very well, I should say. You can use like Amazon's IoT product to do that. But again, you're at that 5 minute window of execution. So it's kind of a little wonky. And if you are doing anything real time with WebSockets, that also might be an issue for you. And then another thing that a lot of people talk about when they're talking about serverless and some of the drawbacks, they mention cold starts. So what a cold start is when a Lambda function or whatever, provider you're using, the function starts executing. It needs to spin up that container to actually execute the function if that container is not already warm. So there is a little bit of latency added if it is a cold start. And that latency depends on a number of factors, including like what runtime you choose to write your code in, as well as like how big the actual code and the dependencies are that run. But yeah, so if you have requirements that are basically require like super, super low latency, you might run into some issues with some of the providers unless you choose to kind of supersede that with running your own kind of functions as a service platform inside of Kubernetes, inside of your own kind of cluster.
So when you're using a language, say like Java, that has a just-in-time compiler, how does that kind of all play? How does it spin up the container, compile the code, be able to execute it? Is it going to be slow because of the JIT?
Yeah, I don't have the exact numbers on Java, but it is the slowest cold start. So if it is kind of like a request response kind of function that the user is waiting for something, you might want to look into that or use another runtime like Node.js, or AWS just released Go. Go is actually the fastest because it's that compiled binary. And I'm pretty bullish on like the Go kind of ecosystem right now because it's crazy fast.
So you mentioned Go, we talked about Java. What are some of the runtime platforms that are supported across the different cloud providers right now?
So in AWS, you have Python, Node.js, Java, you have Go. You can actually shim a lot of languages that they don't natively support. So I know someone got Rust working in Lambda, and there's actually Go support before there's official Go support. There's a project out there called Apex, which is written in Go by TJ Holloway-Chuck. He basically shimmed Go to run in like a node instance, basically.
It's interesting. I'd like to know more about that. I ran into this little prototype I was telling you about. It was with Python, and I was using a library that had a JDBC bridge for Python to talk to Athena for this project that I was kind of prototyping. And I ran into a problem because that bridge required Java. It required a JDBC call on the back end. And since it was a Python language, I didn't have the infrastructure. So I ran into a blocker there on trying to actually implement it against Athena.
Yeah. So you can, whatever binary you want, you can kind of shove into that Lambda function. You might run into like some performance issues if you do that. Because again, you're, combining maybe too many things into one function that's kind of meant to be tiny. And again, the more dependencies that you have, that can impact the cold start times.
So that's another thing that you need to think about. You said it's kind of meant to be tiny. What are the kind of the requirements about like the size of the artifact that you deploy with serverless?
There is a max limit of how big your asset can be. But yeah, there are numbers out there where, and I'll try to find you a link. Brian LaRue, who is also an author of another serverless framework called arc.codes. He has a lot of information around this where they try to keep their Lambdas under 5 megs to keep cold starts like at their minimum. You really have to, choose your dependencies wisely, as it were, and or maybe even rewrite some that are just too big. And then in the like JavaScript ecosystem, there's this concept of, tree shaking out unused code. So depending on what you use, if you're using like some sort of bundle like Webpack, instead of including all of Lodash or all of some huge library, you can only include what you need. And that also can help.
Yeah, it doesn't take long to get to that size max if you're just adding new packages. It doesn't take long at all. I mentioned during the introduction that you work on something called the Serverless Framework. What is Serverless Framework in relationship to what we've been talking about?
The Serverless Framework was kind of born out of this need. And I believe you ran into this problem as well, personally.
Yes, I did.
When you're getting started with Lambda or Azure functions or whatever it may be, it's super simple, right? You're writing a really simple function to do maybe some data transformation or whatever your use case might be. Super easy to zip that up with the dependencies through their UI and boom, like it's behind an endpoint, it's live. You're like, wow, that was super easy. But now, like as you start to build out your project and add more functions, and then other teams start adding more functions and et cetera, et cetera, et cetera. Now, like it's untenable to actually do that through the UI anymore, unless you're kind of, a masochist and like doing things the hard way. So it's highly, highly recommended that you use some sort of framework, whether it's the serverless framework or any of the others out there. You're going to have a bad time if you don't have some sort of orchestration tool to manage larger projects. Because in the real world, like code typically never gets smaller, right? And projects never like, oh, we're going to get rid of all this stuff. It's always an additive thing.
Yeah. But what does Serverless Framework do for you? I mean, what does it offer you? You mentioned, like, for example, that you write your code, write this Python function, you zip it up, and then you're going to upload it through this UI. The Serverless Framework does the same thing, right? What does it offer you that the other approach doesn't?
Right. So basically what the framework will do is you write a config file, which is a serverless.yaml file. And that's the configuration of like what your function code is and what event will actually trigger it, whether it's an HTTP event or a cron or maybe an SQSQ or a SNS topic or Kinesis stream. There's a number of different event sources out there, but you define that in your serverless.yaml and any other dependencies you might need, like a database or more S3 buckets or whatever it may be with CloudFormation. And you type in serverless deploy, and the framework, it's just a CLI tool that will go ahead and zip up all of your code and the dependencies, put that into the S3 bucket, and then wire up, endpoints if you've defined an HTTP event, or wire up the Lambda function to respond to the S3 bucket event that you're listening to. It just depends.
Yeah, it's that wire up part that I found so nice. It wasn't just the individual step of creating the serverless function, but it was wiring the events, configuring the gateway, configuring all the things that you need to be able to actually use that endpoint.
Yep, exactly. And then kind of the other benefit is because we're like under the hood, it's actually transpiling down into CloudFormation. You basically get a kind of versioning scheme out of the box where you can roll back functions or roll back the entire stack to a previous state, as well as deploy the exact same infrastructure as code into multiple stages.
As we've been talking, we've used words like S3 bucket, we've used Kinesis, we've used Lambda, we've used things that pretty much is AWS. So is Serverless Framework just an abstraction that sits on top of the AWS services?
Originally, yeah, we only supported AWS. That's kind of how it started. But there's actually, so in serverless.yaml, you can actually define whatever provider you want that there is a plugin for. So right now, I believe we support 8 or 9 different providers. Yeah, so we support AWS, Azure, Google Functions, OpenWhisk. That's a project out of IBM. Kubeless, which runs on your own Kubernetes cluster, Spotinst, which is an interesting one because it actually will run your functions like cheaper than Lambda, Webtasks, and then also Oracle functions. So it's really like as a company, our whole thing is like we're vendor agnostic, where we're really just trying to push the idea like write your code in functions so they're easier to manage. They follow the Unix philosophy. They do one thing, they do it well. We don't really care where you run it, and we don't make any money from giving providers the code in their cloud. So.
Help me understand that. Okay, so we'll just talk about the cloud providers. So you mentioned GCP, you mentioned AWS, you mentioned Azure. They offer kind of similar services, but they're not exactly commodity between them. So how does serverless.yaml abstract out specifics that are differences between AWS and Azure, for example, or does it?
Yeah, so across the different providers, there are some slight differences depending on which provider you're using. But for the most part, the serverless.yaml config is just like, what provider, a provider key, and then what functions, and then inside of that functions configuration, you are defining like what event you want to trigger. So HTTP is pretty similar across the board. Blob storage is pretty similar across the board. And queues are pretty similar. Other than that, it does get a little bit different per provider, but yeah.
So if you keep to the basics of the serverless function and queues maybe, and API, the HTTP gateway type stuff, that's going to be pretty consistent across the major cloud providers?
Yeah. And that's been one of the biggest challenges with the framework and, maintaining this Switzerland type position that we're agnostic to everything, use whatever you want. So because the providers have those differences, it's been a challenge to abstract them completely and give all the functionality of all of them under the hood. But yeah, the cross-cloud world is still a work in progress, I would say.
Sure. So one of the arguments that I used to hear a lot about, using serverless was, you're locking yourself into AWS, for example, or Azure or GCP. Are you now locking yourself in to serverless framework in addition to having a lock-in on something else? Or is there, an escape, get out of jail free card that serverless framework offers?
Yeah, good question. So yeah, there is actually a get out of jail free card. So if you're using AWS and the other providers, we're transpiling down to their native resource manager. So, if you're using AWS, when you actually run serverless deploy, we transpile that into CloudFormation. So if you look, there's actually a hidden folder generated in your project, the .serverless folder. You can look in there and there's the full CloudFormation template for you. So if you ever did want to just use, raw CloudFormation, your team all gets up to speed on the kind of verbosity that entails, feel free, take the CloudFormation and run with it.
In full transparency, that was a total softball pitch because I know for a fact I was talking to David about trying to figure out some parts about CloudFormation, and he was talking about, that we just transcompiled directly down in. You can go look and see exactly what it was. So it's a nice little escape hatch to be able to kind of look at the CloudFormation to be able to see exactly what's being created. So it's very nice.
Yeah. That's one of my biggest, my favorite things about what we do is that if I very much do not like locking people into anything. It's just kind of the ethos in which I'm a developer. It's especially when you don't need to. I don't really like that.
We've been talking a lot about the cloud providers, AWS, GCP, Azure, but there's an on-prem solution too with Kubernetes that you can use, right? Can you talk a bit about Kubeless and what it does?
Yeah, sure. So Kubeless is basically very similar to Lambda, except you're running it in your own Kubernetes cluster. And they expose a number of different events. So like HTTP, they have a scheduled function, so you can run functions on cron, and also a pub sub. So subscribing to a given queue, if you will. Some people were scratching their heads when we added this because, is Kubeless serverless? I say yes, as long as I'm not managing the Kubernetes cluster. So there's Kubeless. There's also the FN project. So that's actually also running in a Kubernetes cluster that just came out from Oracle. And we just added support for that in the serverless framework. And that's kind of a bring your own Docker container. So like whatever container you want, you can run as a serverless function. You obviously want to be careful not to, if it's a latency, like if it is a request response thing, you don't want to, spin up a super big Docker container.
So what does that mean? You define like a container, and then when you write your function, it's deployed into that kind of templated container. What does that mean when you say kind of bring your own container?
So you still would like write your functions. So they have it. It's actually, that project is more convention driven. There's a folder of functions. And then that function, you can define any resources that it needs. There's a bunch of different pieces to it, but they actually do things to make sure that containers stay warm, as well as a number of other things.
Let's talk about the developer experience using serverless. You said it's a CLI tool. So if I'm at a clean terminal, how do I go about getting serverless, and what does the kind of workflow look like for me to write a simple function and deploy it out to, let's just say it's AWS?
Yeah, sure. So to install serverless, you just need to install it from npm. So just npm install serverless. You can install it locally into your project, or you can install it globally with the -G flag. But then, once you have it on your machine, you need to set up like whatever provider you're using. So AWS or Azure or Google, what have you, you need to configure your credentials on your machine. And if you have an AWS account already, those should already be, in your AWS profile. And then basically you can use the create command to use a pre-made kind of template that ships with the framework, which is, all the different runtimes are supported in there. Or you can actually use the serverless install command and just pull down a given Git repository. So there's like a huge kind of ecosystem out there. And we have all these in a Git repo, github.com/serverless/examples. There's like a huge list at the bottom of like community projects that you could literally just, serverless install, give it the URL, and it'll clone that down to your machine and like install the dependencies for you.
When you deploy the actual serverless function, then what happens?
So when you deploy the function, basically we'll package that up, and then based on whatever profile you give it, it will go ahead and create the CloudFormation stack for you, all of the resources. So again, all of the functions and events you define, that all translates down into like a pretty verbose CloudFormation template, which again, you could write yourself, but that might not be the best idea. And then it will go ahead and deploy that up into your AWS account into the given region that you've specified.
And then what does a development or a debug experience look like? Are you typing deploy every 5 minutes, pushing this out there? Is there a local environment? Does it interface with like SAM from AWS? What does that kind of local experience look like, or local development?
The local development experience in the serverless world is still, in my opinion, like lacking, right? So you can emulate your functions locally. We do have an invoke local command. So I can write my function code and then use serverless invoke local and pass it in, the data that it needs. It kind of breaks down if you start touching any other piece of infrastructure, especially if you're not connected to the internet, because, we don't for us to mock all of it, the AWS services, that's a whole nother company in and of itself. So I believe until cloud providers basically release, there are ways to emulate a lot of AWS services locally. There's a project called LocalStack, which will do a number of them. You can run DynamoDB locally. Like there are some of them that you can emulate, but it really depends on what you're using. So typically I'll actually deploy things up, and when you deploy, you can actually just deploy the function code, which is super quick. I mean, to deploy that up, it's like half a second or something. And then you can just ping the live thing. I'm in the camp of, I want to see it work in the actual thing that it's going to be running in. I've had just too many horror stories of like worked on my machine and then not where it actually ends up living.
Then how do you go through kind of a development stage, production kind of scenario, how do you break out kind of the different stages of an application that you're working on?
That's like the beauty of, using CloudFormation stacks with basically the stage name that you give it. And this goes for every like infrastructure as code tool. If you're writing it in such a way where none of the resource names are hard coded, you can actually prefix or postfix the stage in all those things. And then basically you can deploy that thing as many times as you want, as long as you give it a different stage name. So the way that I typically do it is I'll work in a development stage. And when I deploy that, by default, the stage is actually development. Or you can pass a -- stage flag to any CLI command, and that'll actually deploy that up to the stage. You can use whatever stage names that you want. So basically, yeah, that's how I recommend kind of handling that. So once you have something deployed into a dev stage or a QA stage, let's say, and I guess we'll talk about CI/CD in a little bit, but yeah, you can basically, test that stuff out. Is it working? Cool. Then I can actually deploy the exact same thing with the stage of production.
Okay, so you just mentioned CI/CD. How does Serverless Framework fit into kind of the CI/CD or DevOps mentality?
With CI/CD, it's very similar to how you do it now with really anything else, where it's like you just basically install the serverless framework in your CI/CD system. We use Travis, but yeah, use whatever you're familiar with. And then basically we deploy on any PR, we will actually deploy the entire serverless stack into a stage, which we actually prefix with like a date timestamp. So we can do this like continually, because if you keep deploying the stage, sometimes like different jobs run into each other. But basically the entire stack spins up with that unique prefix or postfix. Then integration tests run. If all the integration tests pass, then we can promote that into production or into staging or QA, whatever kind of your flow is. So it's really just installing serverless as part of your CI flow and making sure you have your AWS credentials or whatever provider you're using credentials to use.
And then using those stage to be able to migrate it through the different layers or different not environments that you're moving through. Okay.
Yeah. And then the beauty there is like, when you deploy that thing, the integration tests run, everything passes, you're ready to like promote something to production. With serverless remove, it basically removes that entire CloudFormation stack. So your AWS account stays clean and you like can do that as many times as you want. As long as you don't hit any AWS limits, which sometimes you might, depends on what you're using. Every service is slightly different in there.
AWS, for example, I forgot what it's called, but released this ability to do canarying with AWS. How does the serverless framework like hook into that capability that AWS offers, but maybe Azure doesn't or a different provider doesn't?
Yeah. So the canarying thing, I think it's a first-class citizen in SAM right now. You can do it with the serverless framework. You just need a plugin. So yeah, one of the things I would mention is the serverless framework has a lot of defaults in there. If it doesn't necessarily work for your company's workflow, there's basically lifecycle hooks throughout the framework that you can overwrite with plugins. So like some good examples of that is like if you want to use like TypeScript or some other transpiling step, or if you wanted to use the blue-green deployment stuff. Typically, plugins are a way around a CloudFormation limitation until it's natively supported in CloudFormation. So people will write a plugin for it. So another example of a plugin is there's a plugin to keep your functions warm. So pinging them every 5 minutes to make sure that you have that warm container, stuff like that. So, and there's a huge list of the plugins. There's actually a command in the CLI to view all of them, but I recommend going to github.com/serverless/plugins. There's a huge list of all the different plugins.
Is it like a lifecycle hook or something that I don't know that I understand? What I get the pinging it, but how does it get triggered? What does it do? What does that look like?
Yes. So the serverless warm-up plugin, basically when you deploy, after you've deployed, the plugin will run basically just custom SDK calls to set up a cron to ping your functions that are in your service. So it's It's almost like you're setting up your own function with a cron, and that cron was like doing it for you, but it's just not, you don't see it in your serverless.yaml. That's what that specific plugin does.
So it's basically code that you can use to support your serverless function that does other things, the plugin.
Yeah. One of my favorite ones is actually like a serverless manifest plugin that will basically take all the outputs from your CloudFormation, and then you can use those like in the front end of your application, let's say. So it's basically like the lifecycle hooks in the serverless framework are like run something, before package, run something after package, run something before upload, after upload, and basically when everything's done, I can't remember how many hooks there are, but it just depends on what data you need and what custom functionality that you want. So there's also a plugin for using step functions as well, right? So when step functions first came out, it wasn't supported in CloudFormation. So someone wrote a plugin for it, or you define your state machine. And then after you've deployed your functions, it'll go ahead and wire up the state machine for you. Now I believe it's natively supported by CloudFormation.
Let's talk about the open source nature of the serverless framework. Is all the work done on GitHub? Is this open for contributions? What's kind of the open source story?
So it started as an open source project. It used to be called the JAWS framework, but then Austin got sued by Steven Spielberg. No, that's not true. It was an accessibility tool called JAWS, so it was like a name conflict. But yeah, so it started as an open source project, and yeah, it'll always be open source. So github.com/serverless/serverless, tons of community contributions. It's actually kind of to the point where the community kind of runs most of it right now, which is awesome. And we have some really good core maintainers that are really helping us out there. Yeah, so if you're interested in getting involved, check it out. We love new ideas, feature requests. Just open up an issue or open up a PR for that matter. Even better.
Well, if you liked what you heard and you want to learn more, David's going to be running a workshop at KubeCon New York. That workshop will be all about the serverless framework and serverless. So be sure to check it out if you want to dive in and learn more about the serverless framework.
And I'm excited about the workshop. We're going to run through like the entire framework, all of the different event sources, and like how to build like a production ready serverless app. So check it out.
David, thanks for joining us on the InfoQ podcast.
Yeah, thanks for having me.